Good day, class. This is the second part of the tutorial on the topic projectile motion problem solving. Projectile launched at an angle. Let's get into this. The first part of the problem-solving tutorial on horizontally launched projectiles is available on the link below. Projectile motion is a motion that follows a curved path due to the combination of constant velocity horizontal motion and vertical motion with constant acceleration. Ideally, it assumes that only the force of gravity is acting on the object for the entire motion. In reality, the force of gravity is always present, and there are other factors that affect the motion of an object like its spin and air resistance. Projectile motion always assumes the absence of these factors, so that we can predict and calculate motion quantities. In order for us to solve projectile motion problems, we need to understand the characteristics of its horizontal motion and vertical motion. Let us start with its horizontal motion. The velocity of an object in projectile motion is constant, as suggested by the horizontal arrow. For its entire motion, the horizontal arrow does not change its length. This means that the velocity of the object does not change the entire motion. The moment the object is released, its horizontal velocity is constant. The horizontal velocity does not change even if it reaches its maximum height and its landing spot. So for problem solving, we always remember that the velocity is constant, and therefore we will use equations for constant velocity motion. If the problem is asking for horizontal quantities, we will use these constant velocity equations. If it's asking for a horizontal velocity, we use equation 1a. If the unknown is a horizontal distance or the range, we use equation 1b. For its vertical motion, we will divide it into an upward motion and downward motion. Focus your attention on the vertical arrow. The vertical arrow is showing a decrease in length as it moves upward. This means that the vertical velocity of the object decreases. Ideally, considering the effect of the acceleration due to gravity, the vertical velocity decreases by 9.81 meters per second. The vertical acceleration is negative 9.81 meters per second squared because the object velocity decreases. This idea aligns with basic kinematics concept, which states that when the object velocity decreases, its acceleration is negative. The vertical velocity of the object at the peak of its projectile is 0, considering that the object momentarily stops before falling back to the ground. For the downward projectile, the object's vertical arrow increases as the object is curving downward. This means that the vertical velocity increases. The increase in vertical velocity is 9.81 meters per second, and the acceleration is positive 9.81 meters per second squared. Remember also that the time for a projectile from its release until it reaches its peak is equal to the time from its peak until it lands on the ground. We will follow this approach in solving projectile motion problems. 1. If the initial velocity is given with its projected angle, calculate first the x and y component of that initial velocity. We label the horizontal velocity as Vx and not V sub I because it's constant for the entire projectile motion. For the vertical velocity, we label it as V sub I because it's the initial vertical velocity, and it changes as it moves along its path. The velocity decreases as the object moves upward and increases as it moves downward. Strategy number 2. Classify the given quantities as those pertaining to horizontal or vertical motion, so that you will not be confused about which ones to substitute into your solution. This is the most critical thing to do when solving projectile motion problems, as it guides you what values to substitute in your equations.
Nice.
Strategy number 3. If the question is asking for horizontal quantities, Choose equations from the constant velocity motion equations. If the problem is asking for vertical quantities, then use the uniformly accelerated equations. Example number 1. A projectile is launched from ground level with an initial speed of 50 meters per second at an angle of 30 degrees above the horizontal. Neglecting air resistance, calculate the total time of flight, the maximum height reached, and the horizontal range. This is the diagram of the situation with its given parameters. We solve first the x and y component of the initial velocity. Then we place them on a table separating the horizontal and the vertical motion parameters. For the time of flight, we will consider the time of the upward motion. The time of the upward motion is 1/2 of the total time. The vertical velocity at the top of the motion is 0, and we will use negative 9.81 meter per second square for the acceleration, since its velocity is decreasing. We will choose from the equations, since we are referring to the upward motion. The time for the object to reach its peak is 2.55 seconds, meaning that for the object to curve downward is also 2.55 seconds. So we will just multiply 2.55 seconds by 2 to get the time of the entire motion. For the maximum height, we will still consider the upward motion with the 0 final vertical velocity and with acceleration equal to negative 9.81 meter per second squared. For the range, we will use the horizontal motion quantities because the range is the horizontal distance of projectile. Thank you for watching this tutorial. I hope you have a great time watching. I'd love to hear your questions, comments, or suggestions below. Until next time, take care always.